Now I'm going to show you how to set up the current limiter, explain a bit more in details about the functionalities, the different, and how to verify as well the current limiter. So the setup I have here is the PowerWave. Then I have an oscilloscope, and in the back there, as you can see, I've connected the load. It's a 1 ohm resistor load, power resistor 2 kilowatt. And also back there you can see I have hooked up a differential voltage probe to measure the voltage at the load, as well as an active current probe, a 500 amp probe to measure the current. And on the oscilloscope, the yellow trace is the voltage and the purple trace is the current. So first I'm going to set up the PowerWave to a AC. So the PowerWave offers different functionalities when it comes to current limitations. It has an RMS current limiter and a peak current limiter, and I'm going to show you how to use which one and which is best practice. So first I'm going to use an AC current limiter. For that I'm setting up the PowerWave to AC operating mode at a relatively low voltage. That's because the load doesn't handle more current at the moment. So 30 volts, 50 hertz. And I leave the RMS limiter disabled. So at the moment it is not limiting the current. So I have set it up to 30 volts. I have a 1 ohm resistor connected, so the resulting current should be 30 amps. And we're going to verify this. So I'm going to hit test on, switch on the output of the PowerWave. And now if you look at the oscilloscope, you can see the yellow trace is the voltage. So it's 28.3 volts. And the current is 27.9, so 28 amps. So it's more or less correct. The slight difference comes from the voltage loss in the cables to the load, as well as the 1 ohm that is not exactly 1 ohm. So now I'm going to change or enable the current limiter. So I go again to the power source setting, the local control. I still leave it in AC 30 volts, 50 hertz. I'm not going to change that. And now there are different limiter modes. So one is continuous and the other one is stop. So first I'm going to demonstrate you the stop. Stop means that the PowerWave will stop the output, disable the output, as soon as the current limit is reached. So to stop, I put it to RMS. So there's a peak limiter in RMS. We will come to the peak limiter in DC mode later. So I leave it in RMS and I put it, sorry, just did a mistake. So I have to go through the setting again. So leave it to the RMS, enable the current limiter and set it to 20 amps. And now it applied the settings, and with a 30 volt output and 1 ohm resistor, the current was 30 amps. Now we set the limiter to 20 amps, so immediately it detected that there's an overcurrent and disabled the output. It's also showing a power source alarm 40, so it's showing actually that it went into the power limiter mode or current limiter mode. Okay? So I'm going to quit the error message with stop, and I'm going to set it up again. Now this time I'm going to first set it into continuous mode. Continuous mode, that means that the PowerWave automatically reduces its output voltage, that the current stays within the limit that I set. So to continuous in RMS, I will disable it first just for demonstration purposes, and still at 30 volts with 1 ohm, so we should get 30 amps. Now on the oscilloscope, you can see we get the purple line, that's an RMS value of roughly 28 amps RMS. So now I'm going to set up the current limiter to 20 amps, and in continuous, I'm going to enable the power limiter, the current limiter. I'm going to set it to 20 amps, And now, as you see on the oscilloscope, the current went down to 21.8 amps, as well as the voltage to 22 volts. So you see that the set voltage is actually 30 volts, but it automatically reduced the output voltage to 21 volts or 22 volts, that the current remains within the limits that is set. And it's still showing the power source around 40, so that's just a warning or notification, hey, I'm actually working in a power source alarm. I'm going to, just for demonstration purposes, going to set it to 25 amps. Apply it. And now the current went to 27.1, so that's about the accuracy I would expect from the PowerWave. Because as I said, the PowerWave can generate up to 236 amps per line, per phase. So we are in a very, very low, actually, current range for the PowerWave. So the accuracy is about 1 to 2 amps in these lower settings.